Okay, I'm doing videos here in my kitchen and my wife is in the background and I would rather have the background noise with her in the room than for me to go to a separate room. So you're gonna have to be okay with that. I hope it's fine. Look at this. Look at this. This is interesting. Identifying skeletal resonance structures. Attempted not yet learned 44%. That's a big number. So this is a homework assignment which is not due for a few days, so it's possible that people are just looking at it. I don't know. But I would say decent chances that that is blockage. So let's do an example of that one. And I'm going to come down here. And the question is, are these resonance structures? Okay. So first thing I'm going to do as a student is I'm going to look at the explanation to see what is resonance structures. And let me screenshot this. I'm not going to screenshot the explanation. I'm just going to go here. Go over to and resonance structures, it turns out, the first thing we need to know is, number one, all atoms in the same place. All the atoms in the same place. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so far, and an oxygen, okay? So far, so good. All right, those guys are all in the same place. The next question is, all charges are the same. And I can see that there's a plus over here and no plus over here, so I'm done with that one. No, this is not. Let's go get a different one. Let's look at this one. Are all atoms in the same place? Well, let's look at it. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, they are. Okay. At least all the carbons are. Let's go back and look at some other atoms. I think the answer is still going to be yes, but no, it's not. Watch. There's 3 hydrogens here. Right? 2 hydrogens here. 3 and 2, those look the same. This one looks different though. Look at that. This has a hydrogen here because it's got 4 electron groups, but here it does not have a hydrogen on it. There's no hydrogen on that. And to convince yourself of that, you should draw out the full Lewis structure. This is not possible because there's a minus on there, right? And that minus means that that's occupying a molecular orbital. So consequently, these are not resonance structures either. They have all the same atoms, but this one has a hydrogen over here, and this one has a hydrogen over here. Now, again, I encourage you to go back to the topic where you draw out all the atoms, and that will convince you that this is the case. That and formal charges. So no, these are not the same because these have different charges. These are not the same because the atoms are not all in the same place. And these are the same. I can see that. I'm sorry. I'm going to go a little faster here. All the atoms are in the same place. I don't see a hydrogen there, but it's there. I don't see a hydrogen there, but it's there. I don't see a hydrogen here. It is there. There's a CH3, a CH3. Yes, these are all in the same place. Now, there's a CH3 here, but there's not a CH3 here. Oh, look at that. There's a CH here. This one's a better example, I think. Let's go back over here. This, I'm going to take a minute and draw it out as if I were a student. This is what I'm recommending you do. I'm recommending you draw this whole thing out. CH3, C, 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 and C. Okay? And this carbon's got 4 electron groups on it. And so one of these electron groups looks like it's a lone pair of electrons because it's got a negative. That is just that, right? Shouldn't have drawn that there. Okay. And this one's got a hydrogen coming off of it, right? And these guys have hydrogen, but this one's got 2 hydrogens coming off of it. Can you see a CH2 right there? So these are not all in the same place. Okay, so I'm not going to get a green if I click check, because I'm just not working right now. So let's click solve and we'll see. It's going to say no, no, yes, no. Watch this. Click. No, no, yes, no. I'm going to do one more example. Let me come through here. 4. Let's do 2 examples at once. Okay, are all the atoms in the same place? Possibly. I have a feeling this is correct, okay? So look, there's a CH off of here, and there's a CH off of here with a lone pair of electrons. That's what that minus means. It's a lone pair of electrons. And there's 2 lone pairs of electrons here, and 3 lone pairs of electrons here. A CH3 here, a CH3 here, an ethyl group here, and an ethyl group here. Yeah, these 2 are these are resonance structures, one of another. And I have a feeling these are too. There's a hydrogen here, a hydrogen here, hydrogen here, yup, hydrogen here, and a CH3 here. Yup, these are both yes and yes. Resonance structures. I know I'm going kind of fast here. Happily do more of this in class or on request. We'll make another video. If this is really hard for you, it's possible that you went too fast with drawing out your Foucault structures. And so if it's, again, I don't mind, I can see these are not, right? There's a CH3 here, and this is not a CH3. The only way to draw that minus on there is with the lone pair of electrons. That is what that is. And this is a CH3. There's no way to, again, if it's a carbon here and you got a minus on it, you have to have that lone pair of electrons on there. Okay? So let's say that is not. And what about this one? This one probably is. I've got a hydrogen here. It looks like if these electrons go here, it does exactly that. Yes. And these electrons go here. Yup, that's resonance. It's going to give that structure. So the answer there is yes. All of my atoms are in the same place, and they're in the same connectivity. The charges are the same, and only the electrons are moving. That's what resonance structures are. So that's going to be a yes and a no and a yes. So yes, yes, no, yes. Watch. I'm going to click solve, and it's going to say yes, yes, no, yes. Yes, yes, no, yes. All right. Hope that's helpful. I'm trying to go fast right now because I don't want to get you bogged down and have a long video. It's 2:30 on Saturday afternoon. I can probably do another one of these today if you ask. We can also talk about it in class on Monday. This homework assignment is not due till Tuesday, so hope this is helpful.